And I'm going to go ahead and get my face off of here so that you won't be distracted. Uh, so when we are talking about simple and compound interest, first thing we want to do is understand what interest is. And interest is money you earn when you invest money in a bank or money you have to pay extra if you borrow money. So if I invest $1 and the interest rate is 1%, then that means I get a penny extra at the end of the year. This is because there's 100 pennies in $1, so you can visualize 100 pennies, and one penny is 1% of 100 because 1% of 100 is 1. So take that extra penny that I get for interest at the end of 1 year. So if the interest rate is 5%, then it earns 5 cents or $0.05 at the end of 1 year. So I would have $1.05. That would be my original dollar plus the 5 cents I earned in interest. So that's kind of how interest works. We're going to talk about simple interest first because, as the name suggests, it's pretty simple. Simple interest is calculated when you multiply the interest rate, that 5% or that 1% or whatever, by the amount invested or the amount borrowed. So if I multiply 0.05 times 100, I get $5. So that would be the amount of interest. So this happens at the end of each year. So you take that amount and multiply it by the number of years and the money invested or the number of years that it takes to pay back what you borrowed. That formula is I equals PRT. That's I for interest that you will earn or have to pay back. P for the principal investment. So that's the amount of money either you borrow or the amount of money you put in the bank first. So that's your account balance up front. And then you multiply that times the interest rate. That's the R. And that's going to be a percent, but we're going to put that as a decimal to use it as a multiplier. And then the time is in years of the investment. We got to make sure that we understand that I is the interest we earn. P is the principal investment we put in. Rate is a percent that we use as a decimal in our formula, and the time is in years of the number of years for the investment or the amount of years you borrow the money. And this will give you the amount of interest accumulated after that number of years. So let's pretend we have this machine, and I'm going to call this my simple interest machine, and I'm going to do $100, and it's going to be invested at a rate of 5%. So this is a simple interest machine. So let's go ahead and put some money in there. And this is going to generate at 5% at the end of 1 year, it gets $5. So that's 1 year invested in there. So I would say I'd take my $100, I'm going to multiply it by the 0.05, which is that 5%. And I'm going to do it for 1 year, and that got me $5. So let's see what happens the second year. So I've already got that $5. That's going to be held off to the side right over here. That's not going to go anywhere. So it's going to stay there. I'm going to take that same $100, and it's going to go back in my machine, and it's going to take the time here and generate, another $5. So at the end of 2 years, I have $10. So this time I'm looking at my formula. I take $100, multiply by 0.05 times 2 because it took 2 years. So it did that twice, and I got $10. And so let's try it one more time. So I've got my $10 in the bank or just sitting over here, and then I take another $100, I put it in my machine, and it calculates and calculates and calculates, and then look, another $5. So at the end of 3 years, let's see, we're going to have a total of $15 of interest that I have earned at the end of 3 years. So I had $100 in my bank. It generated 5% each year. 3 years made $15. If I did the same thing for 5 years, I would just put in the same formula, and I'd get 5%, 0.05 times 5, which is equal to $25. So what if I had an investment of $5,000 at 8% for 6 years? Well, then I would just put that into my formula. I don't have to have that fancy machine. I just put in I equals 5,000 times 0.08 times 6, and I get $2,400. That's how much interest I earned over 6 years at an interest rate of 8% when I invested $5,000. So that means I started with $5,000, That was my initial investment. I earned $2,400 in interest. That's how much I earned over those 6 years. So my account now has the original $5,000 plus the $2,400 or $2,400 I made in interest, which then gives me a total of $7,400 in the account. So the account balance after that 6 years is now $7,400. So not a bad deal. So your turn. Why don't you try the $7,000 investment? We're going to multiply that with the interest rate of 12% in 3 years. So take a few minutes. You can pause the video while you're doing that, or just wait and give you a few seconds to work on that. So if you calculated that in there, you've written down the $7,000, you've changed the 12% to 0.12, and then you multiply that times the point by the 3 years. And did you get $2,520? Well, if you did it right. And just remember that 12% is 0.12. That's one of the mistakes a lot of students make, is converting this. And we talked about this before. If you're confused as to what to do, just remember that percent is per 100. So you can just take that 12 right there and divide it by 100, and you'll get 0.12. That works with any percent. Let's just take a look at another one here. And this one's going to be a little bit different. It's $6,500, an interest rate of 1.5%. And for 9 months. And so I want to talk about this one because some people get confused with the 1.5% and this 9 months, because our time has to be in years, and this one is giving us in months, so we're going to have to do something with that. So in this problem, the time is in months, so I need to first convert it to years. We find this by dividing, I should have said dividing, months by 12. Since there's 12 months in a year, so if there's 12 months in a year, so if I divided 12 months by 12, it would equal 1, or 1 year. If I had 24 months and I divided by 12, 24 divided by 12 is 2, so 24 months would be 2 years. So in our problem, I have to take this 9 months here and divide it by 12, and that's 0.75 years, which does make sense because 9 isn't 1 full year, and it happens to be 0.75 years, or 3/4 of a year. So I'm going to put my values into my formula. My I equals PRT. My P is the initial investment of $6,500. My rate is 0.015 because it was 1.5%. If I put 1.5 divided by 100, I get 0.015. Some of you remember that you just move your decimal point. The decimal point was right here, and I move it once, and I need to add another 0 to move it twice. So that has been moved 2 times, and that gave me the 0.15. And then I multiply it by my time, which we already found was 0.75 years, and that gave me $73.125. Well, this is money, so we always round our money to the nearest cent. Since that's a 5, this rounds to 3. So $73.13 is the amount of interest I would earn. So let's talk about compound interest, because this is different. It's a little bit more complex. I think of compound as being a little complex. And at the end of each year with compound interest, the interest is added back to the investment. So this new total that I get is then recalculated the next year, and it's multiplied by the interest rate again. And that process just keeps going on for the length of the time that the money is invested. So it just keeps rolling back in, added up, and multiplied. So let's see what that looks like. I've got my machine here again. This time I'm going to use a compound interest machine. And what this does is it keeps the money inside the machine and keeps adding to it each year, so that that's what gets calculated each year. So I'm going to start with $100 doing that I did before. It's going to be invested at 5%, just like before. I'm going to put it in my machine here. I'm going to let it calculate at 5%. And after that first year, hey, it made $5, just like it did with simple interest. I still made my $5. But that $5 didn't pop out like it did before. It stays in my machine, and it gets added to that $100. So now my machine, After the first year, I have $105. So I'm going to start working on that again the next year. And this time it generated $5.25 because it was working on $105, not that original $100. So that's staying in my machine, and that's going to get added to the other money out of that 105, and now it's $110.25, and that's at the end of 2 years. So I'm going to calculate again and calculate, and oh, look at there. Now this time, after 3 years, it's going to add another $5.13 there, even though it's $5.51, because that's part of it right there is going to be rounded to 1 cent, not to the other. So that gets added into that, and I end up with $115.76 at the end of 3 years. And now it comes out of the machine because I only did this for 3 years. So it was a 3-year investment. I made actually $5.76 for my investment. But see, and with compound interest right here, it's a little different. We're going to talk about that. That what pops out of the machine is my original investment plus all the interest that I earned. So I got to understand that that value here is different than using my simple interest formula. So the formula for compound interest is A equals P, my principal that I start with, times, now this is different right here. I take 1 plus my rate, 1 plus R, and that becomes one number. And instead of multiplying it times time, I take the time and put it up here. So I'm going to take it as an exponent, which means I'm going to put it to that power of t. And the calculator does that nicely for us. So we don't have to calculate it every year. We don't have to keep putting it back in the machine and figuring it out. So that's what happens with this. And as I said, the difference is that because it keeps adding the interest to the total of the formula, then total formula gives the amount of interest earned with the original principal added to it. So let's take a look at one here. So if I took that same situation and we said it was for 3 years, the calculation was $100. I have 1 plus 0.05, that 5% as a decimal, to the third power of the number of years. And when I put that in my calculator like this, it would come up with that number right here. I would also just change that. You don't actually have to put that 1 plus 0.05 each time. Just know that you take that rate right here and put the 1 in front of the decimal point so it will look like this. So that makes it a little bit easier for us. And if I did it for 5 years, this is how it would look in my formula. And it would come out as $127.60, 3 cents, because that 2 would be rounded up because that's bigger than 5 here, or 5 or bigger. So let's take a look at one that we can do on our own. I'll take the same investment that we did before, the $5,000, 8% interest over 6 years, and I put that in my formula, and I take 5,000 times 1.08, that's the 1 plus the 8% as a decimal, to the 6th power because there's 6 years, and that came out with $7,934.37. What's different this time is that I started with that $5,000 just like I did with the first one, but this formula gave me what I have in the account now, which is $7,934.37. And to figure out what the interest earned is this time, remember in simple interest, it gave us the interest earned. I would have to take the amount that I have in the account now, that's $7,934.37, and I now have to subtract that original $5,000 to tell me how much money I earned. So I actually made $2,934.37 in that 6 years with that investment. So simple interest, when I did that, remember, I made $2,400. And with compounding it annually, it means I keep putting it back in, just like we did. With that new formula, I get $2,934.37. So I actually made an extra $534.37 by using the compounded annually formula, a difference of that $500. So it really it makes a big difference to use the compounding it, which is the way it should work because it's your money and you keep it in the bank and they should keep adding that interest each year. So I hope you are understanding how we can do this. So if I did the $7,000 investment 12% interest rate, 3 years, it's the same thing. Let's see what you would come up with. So put that in your formula, 7,000 times 1 plus what that would be. What would that be? 1 plus 12%. So that's going to give us 1.12, and we're going to raise it to the power of 3. Now, different calculators handle this in different ways. We use the Inspires, and it's just by using that special caret button that looks like a little arrow or a little hat, and that always does it for us. If you're using a standard calculator on your phone, the scientific one, turn your phone sideways. There's a little X to the Y or a Y to the X button that you press to do that with. So it doesn't show it as nicely as on our calculators, but it still works just as well. So did you get $9,834.50? Well, that's what you should have gotten. And just remember that this is the total in the account now. That is not the interest you earned. The interest earned would be this minus that $7,000, which is $2,834.50. I hope that helps you understand simple and compound interest a little bit better. So we shall see you tomorrow.